Hi. Hi. Hello.
Hi.
Pay no attention to those maniacs behind me right now. Okay, everyone looking at this thing?
Yeah.
Okay. The real test will not be so tiny. Yeah. Ms. Smith wanted us to save paper, so I did. Anyway. This first question is not a derivatives question, as you may have noticed. It's a kind of problem you haven't seen in a while, right? For one thing, you haven't seen it because it's tiny, but also, what is this question asking you? Limit problem? Is it a derivative problem? I kind of said so a minute ago. It's not. It's not a derivative problem. What does it mean to be a limit as x approaches infinity? Where in the graph are we dealing with?
The right side.
Which kind of asymptote?
Asymptote going towards infinity. Positive.
Is it a vertical or horizontal?
Vertical. Because x approaches infinity.
No. As x approaches infinity, that means the horizontal asymptote. This is asking right here. This is asking what's happening way over here on the x-axis, right? And that's the concept of a horizontal asymptote. What's happening as you approach infinity? Now, you could remember the horizontal asymptote rules, right, with the degrees or the whatever, but you may forget that, especially with all the other things you have to memorize. So just plug infinity in. You have 5 infinity squared. I have to remember to write as well as speak. Plus 100,000 infinity. Is 100,000 times infinity, that is not a drop in the ocean compared to 3 infinity squared, right? Infinity times infinity is way bigger than 10,000, whatever, 100,000, anything times infinity. So this is essentially irrelevant compared to how fast this part here is growing. So what you're basically dealing with is 5 infinity squared plus 3 infinity squared plus, or sorry, over 3 infinity squared plus basically nothing. So what does this fraction right here simplify into?
Exactly.
5/3. So the answer is? So that's the idea of horizontal asymptotes, right? Where is a horizontal asymptote? When x approaches infinity, and when you have the limit of the leading coefficients, if the ratio of the degrees is the same. Are the degrees on top and bottom the same? They are. That means the top and the bottom are growing by the same rate. So 5/3 is what dictates the actual growth. So all that is there, what concept is to study there, is horizontal asymptotes. That's the concept of brush up on. And a problem like that pops up in the AP test a lot, which is why here in this practice test it's sprinkled in the derivatives test, but it's still good to know. Right, number 2 is more of what we've been talking about. You can't see the problem on your papers. Sorry, this is a blurry, pixelated version. Looks like a Facebook meme that some parent has reshared. So pixelated and terrible. Just because there's no minions on it. All right, so which of these functions are not differentiable at 2/3? What does that mean?
They're not continuous and the derivatives. Oh wait, okay. Yeah. The derivatives.
The derivative is not continuous. That's a requirement. But what else is a requirement?
The function must be continuous.
No, that's for differentiability. You want not differentiability, right? If something is not differentiable,
It doesn't have any meaning.
then you know for certain it's also not. Oh, sorry, I take it back. If something is not differentiable, could it be continuous?
Yes.
Yes.
You can't. Remember, Mr. Picklecar can drive over. That's not his name, but he can drive. You can draw this in one thing, right? Can you drive over that? No. So it's non-differentiable, but it is continuous. So checking for continuity is not sufficient. What you got to figure out is it actually differential? Is the derivative continuous? So the derivative here, go ahead and take it if you haven't yet. It's cube root of x minus 2. Small pen. That should be your derivative for the first one. Now you may be thinking, well, the absolute value is sort of a curveball, right? What do you do with the absolute value? We'll get to that in a moment. Is function number 1 differentiable at 2/3? Can you plug 2/3 into f prime down here? Can you plug 2/3 in right here? Yeah. Will you get 0 on the bottom? No. Will you get a negative number on the bottom? What's 2/3 minus 2? Positive or negative? It's negative. Can you take what root is this, first of all? Is this a square root or a cube root? Cube, it's always the bottom number. Can you take a cube root of a negative?
Yeah.
Yeah. Odd power roots you can. So having a negative number down there is not a problem at all. So this thing is differentiable at 2/3, which means that we can rule out some of our answers, can't we? We're looking for not differentiable, so we know the answers. Which ones can we rule out?
A, C, and E.
A lot easier now, right? But it still comes down to 2 or 2 and 3. This also simplifies the sum, right? This is just a test-taking strategy. What is the only function we need to check?
3.
3, because 2 appears in both choices. You know 2 is not going to be differentiable, right? So it's only a matter of 3. Now, this absolute value thing might throw you off. A skill you should have learned in pre-cal or maybe algebra 2 even is how to rewrite an absolute value into piecewise form. Okay? So because an absolute value is always a piecewise function in disguise. So 9x squared minus 4. Well, before we even talk about the inner part, what does an absolute value do to a function?
Makes it positive.
Makes what positive?
All the way back.
Not all of them.
The outcome?
In a way. For example, what's the absolute value of 5?
5.
5, right? Do you change anything then? No. What's the absolute value of negative 7?
7.
So you only change what numbers?
The negative.
The negative ones, right? So the real question is, if this outcome is positive, then the function is 9x squared minus 4. There's nothing to do, right? The real question is, when is 9x squared minus 4 negative? Because if it is negative, then you have to change it. Now, 9x squared minus 4, we got to think, is that thing ever negative?
No.
You sure?
Because the negative is always a positive.
9x squared, I agree, is always positive. What if you plug in 0 in there?
0, then it's negative 4.
For example, we look at negative. So we need to figure out where is 9x squared minus 4 positive and where is it negative. It's very easy. 9x squared minus 4 equals 0. That'll help us figure out where it's equal to 0, and using something similar to what we just learned, we can figure out the positive and negative aspects of it. So that means 9x squared is equal to 4, which means x squared is equal to 4/9, right? Which means x is equal to the square root of,
2.
or rather just 2 over 3, right? Is that right?
Yeah.
Wrong. What's the square root of 4/9? 2/3 and negative 2/3, right? Very commonly mistaken. You have a quadratic here, a second power, so you typically have 2 solutions. Now you can probably already kind of notice that here, right? 2/3, 9x squared minus 4, 2/3 is sort of hidden there, but no problem. So that means before and after 2/3, you have these negative values. So I'm going to make a little number line here. And I'm going to populate it with these values that we just got, so the 0 there was not necessary. So have it. 2/3 and negative 2/3. If you plug 0 into this function, what do you get? Positive or negative? The original function.
Positive.
You get negative.
You get negative, right? 9 times 0 squared minus 4 is a negative answer. Which means, just to save time, I'm going to tell you, you get positive on the other side. Typically, in absolute value problems, you have alternating signs, not always. Does this look somewhat familiar from algebra 2 or pre-cal, maybe? I think so? Okay. It is an algebra 2 skill. That's why the number line that we learned in class yesterday should have been somewhat familiar, but maybe not. I'll address that in class tomorrow. So this tells you when this thing is negative, right? Now already you can kind of tell. At 2/3, are you going to have the same function before 2/3 and after 2/3? No, you're going to have different functions, right? So since you have different functions, do you think the derivatives will be the same? They won't. And since the derivatives are the same, the answer would be not differentiable, would just be. I'll spend more time on that one, but I don't want to stress too much on that problem because it's not. It is a calculus problem, but a lot of it's not very calculus heavy. Let's look at number 3. Number 3 is a nice, good, healthy problem. It's not gross. Y equals ln of x quantity cubed, find dy dx. How would you guys approach this problem? What would you do? Power rule. Is that it?
And then the natural log.
Chain rule, which is a natural log, and then if there's anything else, you take the inside part, but there you can see that. So indeed, So if y is equal to ln of x cubed, y prime, or dy dx, same thing, is equal to 3 ln of x quantity squared, which you'll notice is one of the choices. Very tempting, isn't it? A lot of people are going to make that choice. Don't let that be you. Because you remember, chain rule, the party is still raging inside, right? Spilling out. The derivative of the inside part is
1 over s.
1 over s. Do you have any more chains to add on?
Yes, but it doesn't do anything.
Well, if you did add on chain, it would be 1, it would be 0, it would go on to forever, right? So x is sort of the standard term. That's what you have in your old booklets. So once you get there, then you're done. So which of these answer choices does that most closely resemble?
Yay.
A. A is right. So the good thing about a multiple choice test in some regards is you don't have to actually clean it up yourself. You can look at your answer in its current dirty form and say, okay, it looks a lot like this one, so I could clean it up. In this case, it's not hard, but if you know it's there, you know your answer. Now, if you get your answer and it doesn't appear to be any of these, right, then you got to clean it up some and then make it work. Any questions on there? 1, 2, or 3? On the next page, which means next tiny quadrant of this microfilm. This is a trig problem. If we had the full class here, it would be a chorus of groans, but I'll just fill in myself. Oh, trig. Okay, we have our function, and we need to find f prime of that, 3 pi over 2. When in doubt, what do you do? That's not how it goes, but yeah, derivative, which is the product rule, right? When in doubt, take the derivative, but in this particular case, product rule. That's the fourth verse that no one knows. F prime of x is equal to, as Jonathan ruined, surprise, it's the product rule. So just take the product rule. And this one's pretty easy, right? As far as these problems go. We've seen hairier ones in class and assessments. So list out your ingredients, and you're welcome to work ahead of me if you want to. I'm being more concise, or sorry, more detailed than I need to be for all the fans watching at home.
Oh yeah, I didn't read this.
Yeah. Shh. No one came here for you.
Oh.
I'm just kidding.
Alright.
At the beginning, everyone greeted the viewer with a nice hello.
Aw.
Yeah, so if you're watching this later, Jacqueline just walked in a while ago.
Say hello, Jacqueline.
Hello.
Hi.
Gotta go to work soon. Need my life.
There you go. There's your derivative. But dang, it's not an answer choice, is it?
Plug in.
Let's go plug it in, right? This is f prime at a point. So plug it in, plug it in. Now you could do a variety of things. You could plug this in the calculator because this is a calculator active test. I'm a little surprised that this question popped up on the calculator active section here because this is definitely the kind of question on the real AP test it would be on the non-calculator section, which means you got to know your unit circle in and out. So 3 pi over 2 is something like this, right? It's a 60-degree reference angle, which means the sine is going to be bigger, right? So that would be your radical 3 over 2, and this would be your 1/2, your y and your x. Or you can just throw in the calculator. Someone have a calculator handy?
It's 0.
It's 0? Okay. There you go. Sine of x would be radical 3 over 2 plus x, which is 3 pi over 2. Wait a second. 0?
Yeah, I think it's 0.
I think it's 0.
What did that? 1/2.
Is it in radian mode? Cosine is 1/2, right? Square root of 3 over 2 plus 3 pi over 4, isn't it? This is not a choice either. Can we make a big boo-boo?
Probably.
And we're back.
No mistakes.
No mistakes made. Some catastrophic crimes against humanity. And this is gone. The reference angle of 3 pi over 2 is down here, dummy. So it's down here. So that would be a point of 0, -1. And that's where it came from. So sine would be, so ignore all this nonsense. It's been a long day for all of you, all of us at home, I'm sure. Sine of of that will be -1 plus 3 pi over 2 times cosine, that's the x value, that's 0, and that's where -1 comes from. Or, moral of the story, wait, wouldn't that be -1 and not 0?
Yeah.
You sure I put it in right?
Yeah, I believed it, but on accident, trying to look at it.
I said I grab my calculator really fast.
Cosine of 3 pi over 2 is 0. It should be -1. Does -1 feel good?
Sure.
Yeah. All right.
No, 1 second.
Yeah, double check, because I don't want you to go away with the wrong information. Take the derivative. Sine of 3 pi over 2 is -1 plus 3 pi over 2 times cosine, which is 0. Right? And that should be that. We good?
Yeah, I got -1.
Okay.
Yeah, because.
All right. Now to a prettier problem. Now you may think, oh, these decimals are ugly and gross, but whenever you see decimals in the AP test, that normally means it's a calculator problem, because no one gets decimals in it. So go ahead and try to find the tangent line. I'll work along with you for the viewers at home, but I think you know what to do. Oh man.
If you want it, I'll rip some off. I don't like it much. It's pumpernickel.
No.
Yeah.
I thought it was chocolate.
No. It's
gotta
really
be-
upsetting and
yeah.
deceiving.
I'm gonna be dead and pumpernickel.
It's a little bit extreme.
No. Now, this angle of pi over 18 is a monstrosity, you think, but the thing is, throw in the calculator, you see that it becomes quickly pi over 6. And thankfully, this is a calculator problem anyway. Calculator friend says... So now you got your slope. We'll leave it to you to find the points. Should get a calculator alternative to this problem is simply to, if you're in a pinch, you know what to do. Just graph this thing in the calculator and throw a bunch of these choices into your y2 and y3 and y4 and see which ones graze the way a tangent line would your function at pi over 18. Right? It's not the most time efficient choice, but it's better than just guessing.
So if we were stuck on the test, would that be an acceptable way to give the answer?
Yes, multiple choice. On the real test, right? Oh, for you, in terms of Monday. Monday, as long as you have the answer, really as long as you need.
Okay.
In a perfect world, right, you have to have work and answer, but grade-wise, I'm only going to be answer. There's no partial
You
grades.
said that this counts as like an assessment grade?
Yeah, no more or less than anything.
Okay.
Yeah.
So in general, whenever you have the option to circle none of these, will it ever be?
Will it ever be none of these? Not very often. It is usually a very tempting choice, right? And I can see as a test maker why you put this here, because is it any of these choices, or is it anything else in the vast infinite realm of possibility? And that there's a lot more included in that than any of these individual choices, right? But don't rule it out summarily, right? It could be, but I wouldn't. If you find yourself finding all these choices to be wrong, then maybe you'd go back and check it with. Now, the one exception to that is a problem where you have those Roman numerals, right? Those kind of cases. Oftentimes, those are none of these, or none, right? But something like this, normally, it's one. Not always, but yeah.
I'm just a little bit confused at how you got 0.75.
I plug pi over 18 into the original function. It's in the calculator.
Oh, no.
Yeah. A lot of people start there first. You may want to start there first. All right, let's go to number 6. As soon as you see this beast, a clear concept from our notes or homework or what have you should be coming to mind. What topic is this? Implicit differentiation. Why? Because the function is not solved for y. In fact, it does not solve neatly for y. Right? So this is just pure and simple implicit differentiation. So in a sense, you can see why this test was attractive to me to provide to you as a review test, right? It covers usually in 1 or 2 examples all the stuff we've learned in the last month or 2. Right? You got your trig derivatives, you got your tangent lines, you got your implicit differentiation, and this is one of those. So take the derivative, and again, the rule is use the proper rules as you ever would, except if you're taking the derivative of anything that's not an x term, which is normally y, make sure you tack dy dx on it. Only if you're taking the derivative of it. So, for example, here you'll need the product rule. So that'll be 3y squared dy dx times x, that's f prime g, plus f times g prime derivative of x is just 1. So you're more than welcome to work ahead more quickly if you want to, but I'm going to be precise here. So this one's kind of a tough one because you have 2 of these what's called mixed xy terms, right? Where x and y are multiplied together. Each of them requires a product rule. Each of them have, when you take the derivative of the y part, you got to tack on a dy dx in each case.
What was the 6?
What's the derivative of 6?
Oh, yeah.
But very common mistake. And I'm not sure how these choices were generated, but I guarantee one of these choices is if you had left that as a 6. And then the numbers would work out to one of those wrong choices. So very common for this number right here to not be dealt with properly. Now if it's 6x, then it's still 6.
Right.
Right? But if it's a number, 6, 5, 3, whatever, it's always 0. So once you're here, separate your terms. Your good from your bad, your wheat from your chaff. Whatever you want to think of it. I don't know what chaff is, but and the good thing about a problem like this is you don't have to clean it up very much because you can normally tell using a bit of just test taking skills what the good choices are and what the bad choices are. Factor out, and divide, and you eventually get this thing. Which once again is not an answer choice, but notice 2, 1. Plug it in. and cross both. Should get C. See? The jokes are free. So that's a bit of a time-consuming problem. So if you're, stuck for time in a problem like this, implicit differentiation, it gets faster with practice, but you have to keep that in mind. Any issues on that problem? Yeah.
For where you have dy dx parentheses blah blah blah,
Mm-hmm.
how did you? Is that 2x squared y?
Yeah.
Where did that come?
I rearranged it just to be in descending order for x squared and y. So this right here, this right here. That came from the product rule back over here, right? Oh, sorry, right over here. So 2y dy dx, that's f prime, and then g is.
Oh wait, is the 6 supposed to be 0? Like,
What's the derivative of 6? There you got a mistake. As you see. Yeah.
No,
Same thing?
No, I just answered mine.
What issue did you have?
I was just curious as to why it was on the right side on the second step, and then I realized why it was.
Over here?
My hand up. Yes, sir.
So
I realized it.
you're separating the terms, right? Anything that doesn't have a dy dx attached?
Well, yeah, I realized that. I was curious as to where the 2xy squared came from, then I realized it was over there, and you just changed the sign.
Oh, yeah, exactly. So if you want to show the steps of subtracting 2x from both sides, you can, but once you get in the habit, you recognize that as soon as you move something across the equal sign, they become a negative.
I just didn't see the y squared. I was curious as to where that
Right here?
was.
Oh, I see.
I saw it when I was.
I rearranged it. Okay, what do we have next? Is that the end of this page? Well, it's all on one page for you. I'm sorry. Right, now we got this ugly looking problem here, a Roman numerals problem. Which of these functions has a derivative at x equals 0? What concept is that asking about? Having a derivative. Well, differentiation is the act of taking a derivative.
Continuity.
In a sense, continuity of what?
Whether or not it's continuous?
Yeah.
Yeah. Whether or not the derivative is continuous.
Yeah.
So what I would advise that you do is take the derivatives of each of these and see if they're continuous or not at 0. And that takes a bit of work, especially for Roman numeral number 2. I'll show you a technique for that in just a minute.
No. That. No, it stopped. Okay, you're good.
He went to the
You're good.
restroom. We hijacked the screen. It's us.
Yeah, we're gonna lock him out of his room. No.
That's
Beware.
not true. Okay,
Yeah.
gotta go. Bye.
See you later.
Bye.
Okay, so for problem number 7, I heard Mr. Picklecor mentioned. Good idea. So really, you can graph all of these, right? Make sure your calculator is in radian mode. So inverse sine x squared minus 1 minus x.
Let's just jump off.
Now that might look confusing, right? Remember, we're only concerned about 1. Sorry, it's 0. So what happens to him before or after that? That's his own business. He's probably causing havoc anyway, not in Mr. Formula. Now, another way to do this is simply to hit second calc, dy dx, choice 6. Do you get an answer? You do. It's -1. Now that's going to show up.
You don't have to find the exact.
The analytical derivative? You don't. That's a technique to avoid it. Now, is it a good idea to know what the arc sine's derivative is? Of course, because it makes it work. But this one's a little bit harder, because this one requires the chain rule course on top of the inverse sine derivative.
So you'd recommend just plugging it in?
If you can. Now, the actual test problem may not be identical to this, right? But look, the key concept here is to recognize this question is asking you about the concept of differentiability, which is our analogy of can you drive over it smoothly without suddenly changing slope. And if you have a slope, then you get a unique answer. It may behoove you though to zoom in, just to be sure that it's a nice smooth transition. Appears to be. Not pleasant, but doable. And do that for all of them, and I think the answer you get is 1 and 2. No choice. 1 only, I believe. I'll double check that on that. Is that
for the ones that don't have to be 0?
the ones where Mr. Pillar gets stuck? That would be.
Well, the one that said if you do second calc 6, don't come out to be 0.
Oh, or don't have to be not count to be 0. But don't give you an answer.
Okay.
If you get a if it says if you type in, let me just show you an example. Square root of x to the 4. Let's just x squared. That shouldn't be that bad. This one will give you an answer. I'm sorry. So calc. Yeah. That's not. I'm sorry. And finally, absolute value. Okay, so sorry, I should have checked this should be up there. Now, I wanted to give you an example of what it looks like when there's no answer, right? That would look something like this. Now, the cube root of x. The cube root of x is continuous at x equals 0, but there's no chance in heck that Mr. Piddlecart is going to drive over that, right, no matter how fast he's going. So second calc dy dx and 0. Oh crap. I take it back. The calculator is telling you 100, right? That's because the calculator is using numerical methods to approximate the slope. And in reality, it can't go much more than 100 in terms of slope, right? So all it's recognizing right here is that it's very steep, which it is. It's vertical. In reality, what this calculator should be saying is blank. There's no derivative there. Because when you take the derivative of x to the 1/3, you get 1 over x to the negative, x to the 2/3, which is divided by 0. And you can't divide by 0. So the calculator is normally right. I should double check that one. That's something to be cautious about. But what you mentioned, Pearson, I wanted to warn you about, it's not that the derivative is equal to 0. It's that there is a derivative at 0.
Okay.
What that slope is could vary. Could be downhill, could be uphill, could be flat. Yeah.
So on the calculator, we were graphing the original functions, and as long as they're continuous through 0, then there obviously has to be a derivative from 0.
Not necessarily.
Oh yeah.
Just because it's continuous doesn't mean it's differentiable. But make sure it is continuous, that's a requirement, right? Make sure you can plug 0 into it. In all these cases you can. But make sure that Mr. Piddlecart can drive through that point. And you can check that by using second calc dy dx.
So for a question like this, where it says has a derivative at a certain number, you only have to make sure it's differentiable at that one point.
Yes.
The rest of it doesn't matter.
The rest of it does not matter. It's not, is it differentiable anywhere?
Right.
It's not, for what intervals is it differentiable, like it was in the review. This is simply at 0. Is there a slope? And if so, well actually, if so, it doesn't matter. Is there a slope at x equals 0?
Okay.
Unique to find things. Right. I won't take too much of your time. Number 8, if you can look at number 8, it's very small. And all of it's very small. But number 8 I had to change from the original test because we haven't covered mean value theorem enough depth yet, so I had to kind of put an old one in there. You got this function, 3 e to the 2x. And you got this other function, 6x cubed. At what value of x do the graphs of f and g have parallel tangent lines? That sounds like a brain teaser. That's a tough one. Yeah, what do you think?
Didn't you find the derivative of each one and then just set them equal to each other?
Why is that?
Because the derivative is slope, and you want the slopes to be equal.
Because the slopes that are equal will result in
parallel.
exactly parallel lines.
Ha! I'm
Very good.
genius.
Very good.
That's
So I got it.
Lots of people are.
No, that's good. That's good. I'm good proud. So exactly, take the derivative, set them equal, find x. Now I'm going to show you a technique because you'll notice analytical methods will not give you these answers, right? You're not going to crunch out negative 0.391 by hand. So there's a lot easier way to do this. But take the derivative of each. F prime is 3 times e to the 2x times 2, which is 6 e to the 2x. And take g prime, which is simply 18x squared.
Would it be 6 e to the 2x minus 1?
Where would the minus 1 come from?
Well, when you take the derivative, you move the 2 down.
No,
and
no.
then
See, that's when you're taking, it's the power
yeah,
rule.
it's E, sorry.
This is the exponential rule.
Okay.
Very easily confused. Yeah.
Like, can you explain how you got the derivative for E again? Like,
Sure. So the 3 is just a coefficient, so that's not gonna make any difference. Well, e to the 2x, the derivative of e to something is e to that something, times chain rule, the derivative of that something, which is just 2. Now, you could try to solve this by hand by setting them equal to each other, although the recognition there that you want to set them equal to each other is the key part of this problem. But once you know that you have to, this is where Mr. or Mrs. TIE4 will help you out quite a bit. Simply plug one of those functions into y1, doesn't matter which, and plug the other one into y2. When they're equal algebraically, what is true about their values graphically?
Go cross.
The cross, right? We're looking for where they cross. There's one graph, and there's the other. Kind of a mess. That's okay. You'll notice that all of our answers here are less than are negative, and they're also very small numbers. So this will give you an idea of where to put the cursor to help you get the exact answer. So if you don't remember to find where they cross, that would be second trace or second calc intersect, choice 5. Now I would move, so first curve and second curve, sorry, is just where y1 and y2, so enter, enter. And I would move the cursor kind of in this negative vicinity, that way it knows if there's multiple intersections, this will tell it to go in the right place. And you get negative 0.3906. Is that a choice? There it is. Number 2.
What did we do? What exactly?
So this is y1 or y2.
Okay.
This is the other one, right?
Right.
Where they're equal, algebraically, is where they cross graphically. So once they're in there, second calc intersect. And then basically press enter 3 times. It's very picky.
Okay, so 8,
And then voila, it'll get you the answer.
second calc intersect.
That's where they cross. Number 9, number 9, number 9. Similar problems in some regards, but I want you to be careful on how you read number 9. Which of the following is an equation of the tangent line to that function at the point where f prime of x is equal to 1? What have they given us? What is this right here?
The derivative.
The derivative or the slope. They have not given us x equals 1. So the very common mistake a lot of people are going to make, and they're going to get this neat answer right here, which is wrong, is to assume that x equals 1. That is not what they told you. They have told you that f prime of x is equal to 1. And the important realization there is it's the slope. So go ahead and find f prime algebraically. F prime, if you can't read this problem, it's not a surprise, it's tiny. X to the 4th plus 2x squared. So the derivative would be 4x cubed plus 4x. Well, that's f prime of x. This is f prime of x, and they say it's equal to 1. So what must set it equal to 1? Exactly. Now you might be thinking, well, crap, Descartes' rule of signs. In fact, no, don't do that. I probably forgot what that was. Once again, your old friend TI-84 can come in and rescue the day. Simply, just like the last problem in some regards, you want these two quantities to be equal. Simply place one of them in y1, one of them in y2, see where they cross, and move on to the next one. And you can normally tell when a problem is going to involve a technique like this when the answers are all decimals like that. Because no one in the right mind is going to actually work those out by hand. So you want those quantities to be equal. That's when they cross graphically. Second calc intersect. Please, thank you, thank you. There's your x value. That's not an answer choice. Peculiar. Shouldn't be. That is the x value for which the slope is 1. So x will equal 0.237. Okay, fair enough. What is f prime of 0.237? We already know this. That will produce 1. So we have our slope, we have our x value. What's the only other thing we need to write the equation of the line?
Oh, why?
The y value. So throw 0.237 back into f. So f of, not f prime, but f of 0.237 will give you, I don't know, 237 to the 4th power plus 2.237. Any of you seen The Shining?
Yes.
Room 237, very scary. 0.115. There's our x, there's our y. We already had our m to begin with, right? Throw them into point slope, and you'll have your x.
Wait, what was our n?
M was 1.
Right.
We had to figure out where the slope was 1. That's where this stuff here came into play. That allowed us to find the slope. So that's where the calculator produced that value. Once we had that value, we plugged it back into the function to get the y value, which we couldn't do until now anyway, so we have x. Now we do, throw in a point slope, and you get your answer. Okay. Everyone good for 8, 9? Number 10. Tangent line, this is a hard problem. The one that I chose for the real test is a little bit easier than this one. Tangent line drawn to that graph at the point 1, 2 forms a right triangle with the coordinate axes. The area of the triangle is pretty peculiar problem, right? This is more like what you'd see on those problem-solving things with the end of the chapters on the big paper, but still not too hard. There's a couple things you have to know. One is, what of course, is what is the tangent line, right? What's tangent? Oh, that was out of ink. What is a tangent line? Well, how do you find a tangent line in general?
Derivative.
Derivative, right? I'm going to show you a little technique here. We don't really need the tangent line so much, right? Well, we do, but not in a huge way. Thankfully, we have our old friend, the TI-84, right? We're wearing this thing out. We want the slope of the tangent line, because what do you need to write a tangent line? You need a point, already provided, and a slope. Well, no one asked for the derivative of this problem. We just want the slope of the tangent line. So throw this bad boy into y1. Remember, this is f, right? It's not f prime. We cannot find f prime algebraically with a calculator. Someone's very excited about that. That's good. If anyone's listening to this on headphones, I'm sorry. Right, so it's that. So that's our function. We want the slope, which this thing can give us. It won't give us a derivative function, but it will give us the slope at any point. Do we know where we want the slope? At 1, right? So second calc, dy dx at 1. Now the slope's not really negative 0.999999973. It's really negative 1, right? Again, the calculator is using approximation methods to do this because you can't memorize everything. You can't actually do the derivative. So that means f prime,
dy dx.
and then type in, and then 1, which is the x value.
Just press 1.
Mm-hmm. After you press 6, right?
After I press 1?
6 to choose dy dx.
Okay.
So that means f prime of 1 is negative 1, right? So let's think here. Y minus, what's the y value? It's 2, equals slope, we just found, x minus the x value, which is 1. So this problem becomes negative x plus 1 plus 2, go ahead and moving this thing over, right? Or y equals negative x plus 3. So look how fast that was to find the tangent line, right? You don't actually need the equation, you need the slope, which the calculator can do for you. In most cases, not all, but most. Sometimes it's deceiving, but not all. No. Well, the geometry aspect of this problem, which is what makes it kind of a confusing one at its face, is to realize it wants the area of the triangle. Well, that's not too hard. You can graph this thing on the calculator as I just did, or you can just kind of visualize it. You know the y-intercept is 3. What's the x-intercept going to be? What makes this thing 0? 3. What's the area of a triangle with base 3 and height 3?
Half 1/2 base times
6 times 6 is
3.
3 times 3 is 9 times 1/2 is
4.
4.
Where'd you get the one? Oh, area.
Area of triangle. Which you should never memorize. I mean, you gotta memorize great, but area of a triangle is just half a rectangle. Rectangle is a base times height. Let's see if we can finish this thing, because I don't want to leave you without it. So a hard-looking problem on its face, not too hard with a bit of calculator trickiness. You could do it by hand, same math, it is more time-consuming. Number 11. You've seen problems like number 11 before. Continuous and differentiable. What must be the values of n and b? In a sense, this problem is redundant. Can something be discontinuous but then also be differentiable? No. You can't have a hole and then expect a tangent line to hug it, right? So essentially, differentiable is all you need. But whatever. You plug in 1 into the function, what do you get on top? You get 3. Plug in 1 here, you get m plus b. What must be true about these two things?
It must equal.
They must equal. M plus b is equal to 3. This is the definition of continuity, in a sense, we're kind of abbreviating. The left must equal the right, must equal the road as well, but the road isn't road as well. So that's one of our conditions, m plus b equals 3. Well, for it to be differentiable, the same must be true of its derivative. The derivative is pretty easy. It's negative 2x, and it's m, right? And the conditions are still the same. X is less than 1, x is greater than 1. Plug it in, and you get negative 2 and m. What must be true of those? They must be equal in order for the derivative to be continuous or for the function to be continuous. So already you can rule out some of your choices, perhaps. You can rule out choice B and choice A. And it's not negative 2 in either of those cases, and you know it has to be. Well, if m is negative 2, and m and b must be 3, what makes 3 with negative 2? If I owe $2, you need $3, the difference is 5. So the answer is 5. Or just plug it in and do the arithmetic. So if I went fast there at the end, let me fill in those gaps. M is negative 2, so now we know negative 2 plus b is equal to 3. Add 2 to both sides, and you get 5. Or just think of the idea, you know, someone bought a $2 item, they give you a 5, what's the change? Good 11? Number 12 is almost, oh, sorry. It's not insultingly easy, but we've done enough of these now that a multiple choice problem in this regard is almost, you know what to look for, right? The none of these here is obviously to keep an eye out for. I want to warn you about a couple of these choices here. Choice B is very tempting. Well, maybe not very tempting, somewhat tempting. But I can tell you to rule out choice B in an instant, ignoring all this mess here. You're going to have to look at all this stuff and understand what it's saying. What's wrong with choice B? H approaching X. Right. So you can already rule that out. Right? So, what other choices can you rule out automatically? Choice C. A derivative is defined as the limit of the difference quotient, right? It's the slope at a point as the points become 0. So now we're down to A and D and perhaps E, but hopefully not. What do you guys think? Is A or is it D?
A.
Let's think here. Everywhere you see an X, so remember when we first got these problems, it was a pain to do by hand, right? Because everywhere you saw an X, you got to put in X plus H, right? It was f of X plus H minus f of X over H. So everywhere you see an X in the original function, right? Everywhere here must also be X plus H. And that did not happen right here, right? So that you can rule out. You have negative X plus H squared plus X plus H, that's what this thing right here is, right? Same thing. Minus the original function as is over H, so it's D. So that's just making sure you understand the structure of the problem. Next page, finally.
Oh,
There's one in the back. 15 problems. Be a little bit late, probably. All the functions below, except one, have the property that the original function is equal to its fourth derivative. Which one does not have this property? Let me give you a fun fact about many standardized tests. And this one is not officially, it's not an SAT or ACT, but it's made by some of the same kind of people. Whenever you have a problem like this, it's always a good idea to start at the end. Because the sadists who make these tests always have these kind of problems. You got to test every single one. The right answer is always at the end. Not always, but often. So that you go through the rigmarole of actually doing it, and then you go, oh crap, I had to do that. Because you just started there, right? So I would suggest starting there. It really doesn't matter where you start, because this is a problem where you're going to have to work through it. I'm going to start with e to the negative x, because I don't remember what the answer is. The function is e to the negative x. F prime is negative e to the negative x. Everyone okay with that? It's the negative, chain rule. F double prime is positive e to the negative x. Let's see what's happening here. Third derivative, which doesn't happen much. So in this case, the first and the last are the same. Does that mean choice E is right?
No.
Does not have this property. Right? Very tempting, very difficult sounding problem. What choice D? Can you kind of start doing that when you're in your head for a minute?
No.
You think maybe
Twos will continue.
The twos.
twos are going to compound upon each other, right?
Yeah.
So the first derivative is going to be 2e to the 2x. The next derivative is going to be 4e to the 2x. You're not going to go back to this, right? So
Right.
we found our answer. No. Wasn't the last one, but it was close to the end, which is often what they do. Again, not always. So be very careful with it. But once you notice that this 2 is going to keep compounding in a way that these negatives didn't, then the answer becomes clear. This one's not too bad. It's ln of t over e to the t. Now you might be thinking, well, I thought ln and e were opposite operations, so maybe I can do some cancellation trickery here. It's always good to keep an eye out for that, but here you can't. Here you just have the plain old what rule? Quotient rule, right? So list out your ingredients, right? Clean the prep area, wash your hands, and put together a feast. I know I mixed metaphor a long time. Now this one's going to require some cleanup, which is also a good kitchen tactic. 3 lessons here. F prime, 1 over t, j prime, e to the t, minus ln of t times e to t over e to the t quantity squared. So that's just quotient rule, plain and simple. It's not a choice. Dang. That's too bad. How can we clean this thing up? Well, there's one obvious way you might clean it up. What do you have on top that appears in both terms? And just like the real ET is tempting to phone home and bust out of being trapped within the graphs of 1 over t and ln of t. So all you just factor it out. But now what do you notice? You can cancel out. So the denominator goes away entirely? Right? No, just one of them, right? This is 2 of what you have here on top. So one of these is going to be gone, leaving you with just 1. But that's still not an answer choice. Dang. Well, still not a problem. And this goes back to something we talked about in a problem that we saw we had to clean up. It was an implicit differentiation problem that then also involved ln. But we had to get rid of that fraction within a fraction. How did we do that back in class?
You multiply it by t over t.
Exactly. And it's well past t time, but multiply by t over t. Be sure to distribute, especially on top. On bottom you have TET, which is a holiday in Vietnam, Tet. And you guys remember Tet Offensive from AP US history? Or
Yes.
anyway. Yes. 1970s. No, 68. Oh, okay. Good. Make sure you distribute here. You get 1 minus t, right? T of t is 1, and that choice is d. So that's pain. It's a quotient rule. But really the question is, how is your algebra? The hardest part of calculus is algebra. And finally, an easy problem to end with. Relatively easy, I shouldn't say easy. None of these are easy. Are you ready to take the derivative of this thing? We need some cleanup first.
Just take
Well, we can, right?
Well.
You can, but I don't think anyone wants to do the quotient rule to this thing, right?
No,
Be a
just
pain.
do the negative one.
Right, so rewrite it first. Don't do any calculus yet.
it.
And now it's ready for the power rule, right? I saw a video recently, or a talk recently by a person who described that, she described this as getting ready for the prom. You want to make sure you show up with the best hairdo and everything, so make sure it's ready, and now everyone's going to do calculus together. Maybe that helps you, maybe it doesn't. So now it's ready to take the derivative, so I think my analogy of that is I say it's calculusable, right? Make it ready for calculus, but same idea. 3x squared minus 2x minus x to the negative 2. There's h prime. Well, you could clean that up, but I wouldn't bother cleaning it up because we don't want h prime. What do we want?
H double.
H double prime, right? So there's h prime. So leave it like this, right? With the messy bun or whatever you want to call it. It's more messy right now. It's popular these days. I've heard. 3x squared is 6x minus 2 plus 2x to the negative. Trace. And now you're basically ready to plug 2 in, but you'll notice these are all fractions. I would give you some advice here. I would write this as 2 over x cubed. Now you can plug 2 in here. This is h double prime. You get 6 times 2 minus 2 plus 2 over 8. 2 cubed is 8. That's 12 minus 2, which is 10, plus 1/4, which is 41/4, which is 8. And that's it. Ready to say goodbye to everybody?
Bye. See you later.
See you in class.